Well, hello there. So today we're going to talk about some of the hardware aspects of using Arduino. So what the pins can do, what voltages you need, and things like that. So these are the two Arduinos that we're using in our Mechatronics class, the Arduino Uno and the Arduino Nano. They both use the same ATmega328 chip, so they're functionally very, very similar. Just a little bit different layout because the Uno has this traditional Arduino board layout with the header pins, the female pins for your connections, where the Nano has male pins and it's designed to plug into a breadboard. Starting with the analog pins, those are like voltmeters that can measure between 0 and 5 volts. They have 10 bits of resolution, so the number that they output is between 0 and 1023. And the analog pins, there are 6 of them, are down here at the bottom of this Arduino Uno. A0 through A5 are how they're labeled. And then over on the Nano, we've got A0 through A7 labeled here. All of the measurements are relative to ground. So this is the plus side of your voltmeter. The red wire on your voltmeter are the analog pins. And then the black wire is automatically connected to ground. So it's always a ground reference. Can't measure negative volts. You can only measure between 0 and 5 volts on those pins. The digital pins are either inputs or outputs, so they can be used to measure 0 or 5 volts, a logic level, as an input, or as an output they supply 0 volts or 5 volts. Very low current, 25 milliamps of maximum current. So you can't drive a motor or something directly. It's enough to turn on an LED or to trigger a transistor. So the digital pins up here on the Arduino, pins 0 through 13 are labeled up at the top. And on the Arduino Nano, we've got D2 through D12 down here, and D13 is around the corner. D1 and D0 are at the top for the Nano. When you're using digital inputs, sometimes a pull-up resistor is appropriate, especially if you're using something like a switch. A switch is a really good, reliable sensor. It's on or off, it's mechanical, you can tell if it's working. And when they're connected to a digital input, we usually are expecting an on-off or a 1-0 high-low kind of a signal. But this circuit is bad because when the switch is open, this digital line isn't connected to anything. And so a voltmeter, a handheld multimeter, will measure 0 volts when it's not connected, but the Arduino is really measuring its internal voltage at that point, and it's not guaranteed to be 0. It's actually a little more likely to be a 5-volt measurement, but it's undetermined and it's not a safe measurement. So this isn't a reliable way to go with a switch. You'll get a reliable 5 volts, but you won't get a reliable off. The right way to use a switch with an Arduino on the digital input is to have a switch and a resistor connected to the power supply. So this is called a pull-up because the resistor is connected to 5 volts. The resistor value is not critical, but something in the 5K range is usually good, 5 to 10K. And then the switch is connected to ground. So when the switch is closed, we get a short circuit to ground. So we measure 0 volts when the switch is closed. When the switch is open, we're connected to 5 volts here, and so we get a 5-volt measurement nice and reliably when the switch is open. When it's closed, when the switch is closed, we actually we have a short circuit to ground and we're connected to the 5-volt, but because of this resistor, this could be thought of as a voltage divider with 0 volts here and 4.7K here, and so you'll get 0 using the voltage divider equation. And even if this is an ohm or 2, you'll get 0.0001 or something well below the threshold for the digital logic low. So this is a very standard way to wire things up. If you prefer your switch to connect to power, mechanical engineers like that, you could do that, and then you would just put 5 volts here and ground here, and that's called a pull-down resistor. Pull-ups are a little more conventional because it's easy to find ground when you're wiring up switches. That's handy thing. And these pull-ups are actually built into the Arduino, and you can use a software command to turn this circuitry on. Then you only have to wire the switch to ground. There are other pins on the Arduino that we'll get into as we look into the other functions in this class, but talking about the serial pins, the I2C pins, SPI, and PWM. These are all other functions. If you look at these kinds of drawings, all the digital pins are labeled here in black, and then in green, the ones that can also do PWM are labeled SDA and SCL. That's your I2C pins. These red ones are the SPI pins. Some pins have more than one function. They can be digital or something else. Also, the analog pins can also be used as digital pins, but we generally don't use them that way just to make it less confusing. But if you need a lot of digital pins, you can double up and make these analog pins work like digital pins too. So serial pins are the digital 1 and digital 0 pins here, and they're labeled TX and RX, transmit and receive. They're over here on the Arduino Uno and over here on the Arduino Nano. Don't use those in general. Those are connected to the USB serial chip. And so if you want to be able to upload programs to your Arduino, you need the serial port. If you use serial for debugging or any other kind of serial outputs, you need to use these. So if you use these for any other purpose, you might have to unwire them in order to program the chip. So generally just leave them alone unless you have a good reason. I2C and SPI are different ways to talk to other chips. So the compasses we're using in Mechatronics use an I2C protocol. SPI is used for things like SD cards, micro SD cards use an SPI communication protocol. And they have special pins because this hardware is built into the ATmega328. So there are 4 pins for SPI and 2 pins for I2C. And we'll talk about those in another lecture. PWM is pulse width modulation, and that's a way to create an analog voltage using a digital pin, and it's turning on and off the pin really fast. And so you can do that only on certain digital pins. They're labeled here with the green on the Arduino Nano, and you can see the little tilde next to the numbering on the board of the Arduino Uno. It's the same numbers though. What PWM or pulse width modulation does is it turns on and off the pin really fast, and this is all automatically handled inside the Arduino. You just tell it what duty cycle you want, and it will continuously make this pulse train. So the duty cycle is the percentage on versus percentage off. So this is a graph of a 10% duty cycle. We're on 10% and off 10%. The period isn't set, or the frequency not set by the duty cycle. That's controlled automatically by the chip. 50% duty cycle is half on, half off. 90% duty cycle, you're on 90% of the time and off 10% of the time. In the Arduino, the analog write function does PWM. You tell it which pin and the duty cycle, but the duty cycle isn't a percentage here. It ranges between 0 and 255. It's an 8-bit number. So if you want 100% duty cycle, 255. 50% duty cycle is 127 or 128. And in terms of pins on the Uno and Nano, it's digital pins 3, 5, 6, 9, 10, and 11 that can do PWM outputs. We'll use these for motor speed control on our robots, so keep track of which ones you can use for PWM. The reason the PWM function is called analog write is because if you filter the PWM signal with an RC filter, a low-pass analog filter, you can create a nice analog voltage that varies between 0 and 5 volts. And the voltage is the duty cycle times the maximum voltage of your pulse. So with a 5-volt pulse, 50% duty cycle gives you 0.5 times your 5 volts, so about 2.5 volts. This is a simulation in MATLAB of a low-pass filter of this signal, and you can see it takes some time to initialize and come to a steady-state value. That has to do with the time constant of the filter, and there's a little ripple each time this changes. It moves this, so you can smooth this out, but that changes the settling time or the rise time. So you have to power your Arduino board. The most common by far is to just use the USB power, because there's 5 volts on a USB port and that works great. The Arduino boards, both of them need a 5 volt supply. So plugging into the USB is easy. There are 5 volt pins. Here's 5 volts on the Arduino Uno, and over here 5 volts on the Arduino Nano. So if you have a separate 5 volt supply, you can use that directly. And if you want to run from a battery, you can provide 7 to 12 volts, anything in that range, to either this barrel jack on the Uno or the V-in pin right here on the Uno, or the V-in pin on the Nano. Those go to a voltage regulator. You can see it's right here, and that creates 5 volts from your 7 to 12 volt range. You need at least 7 to get a reliable 5 volts, or else it might be a little less. And if you go more than 12, this regulator gets very hot, so don't recommend more than 12 volts into the regulator. Those are your options for powering the Arduino. When we're dealing with the input-output functions of the Arduino, the digital, the analog, these are the most common functions we use. Pin mode initializes the pin, if it's a digital pin, to be either the input or the output, and you can also set the automatic pull-ups using this command. Analog read is the analog to digital conversion on the analog pins. Analog write really is doing PWM on the digital pins that can do PWM. Digital read and digital write are the digital control pins. There's good information from Arduino on the boards themselves. I think it's the FAQ tab that has a lot of the useful information. For example, this is describing how the power can be supplied to the Arduino Uno board. So check these links for more information. That's it. I'll see you in the next video.